Hi all, warm greetings to all the listeners of this session. Here is a video on binary search in continuation with the searching in data structures. In the previous video, we saw about linear search, and this video covers the topic of binary search. Before we start with binary search, we need to know what is divide and conquer, because binary search works on the principle of divide and conquer. That is, given a problem, you have to divide the problem into subproblem. That is, the divide and conquer, as the name indicates, it divides the problem into subproblem, and you have to find the solution for the subproblem, and you have to combine the solutions of the subproblem to find the final result. That is, it works in three phases. That is, divide, conquer, and then combine. Given problem is divided into subproblem, that is nothing but the divide. Finding the solution for the subproblem is nothing but the conquer phase, and the final phase will be the combine phase. That is, you have to combine the solutions of the subproblem to find the final result. So the binary search works on the principle of divide and conquer. So in the same way, the given array has to be divided into half, and you have to make a search. So for that, the precondition is the data has to be in the sorted form, that is either in ascending order or in descending order. The algorithm has to be tuned as per ascending or descending given format. So the first principle is you have to divide the array into two halves. So in that mode, you have to find the middle element. So if the target value to be equal to the value, then you have to return that index. If not, you have to move to the left side of the array or the right side of the array. That is, you have to search in the either half. So let me move on with the example over here. Here is an array of 9 elements ranging from 0 to 8. That is the value from 1 to 29, which is sorted in ascending order. So now the target value, that is the search key element, will be 23. Now we have to find the mid value. How do you find the mid value? That is, the lower indexed value is 0 and the higher indexed value is 8. How do you find the mid value? That is low plus high, the whole divided by 2. That is 0 plus 8 divided by 2 will be 4. So mid will be 4. Mid is an index, it is not a value. You have to search the mid indexed value in the given array. So now the mid value calculator is mid index, that is the calculator index is 4 and the mid indexed value is 13. You have to compare whether the 23 is equal to the mid indexed value, that is whether 23 is equal to 13. If it is equal, then you have to return the mid index value. If not, you have to move either to the left half of the array or to the right half of the array. That is, if the given search key value is smaller than that of the mid indexed value, then you have to move on to the left side of the array, that is left half of the array. If the given search key value is greater than that of the mid indexed value, then you have to move to the right side of the array, that is the right half of the array. That's it. Now 23 is not equal to 13. You have three different comparisons. Either the element has to be equal, or it has to be lesser or greater than the mid indexed value. That is, the search key has to be equal to the mid indexed value. If not, it has to be lesser than the mid indexed value. If not, it has to be greater than the mid indexed value. So the first checking will be equal to checking, and the second condition will be less than checking to move on to the left half of the array, and the third condition will be greater to move on to the right side of the, that is the right half of the array. Now the first case is whether the 23 is equal to 30. It is not equal. So the second condition will be whether the 23 is lesser than 13. No. So the third condition will be 23 is greater than 30. So already we know that 23 is not equal to the mid indexed value. Now the right half of the array has to be searched. So in the next cycle, we need not take from index 0 to 4, because 23 does not ranges from 0 to 4, valued from 1 to 13. So for the next cycle of the array that we need to pass is from range 5 to 8. So now the value is 19 to 29 will be passed to the next cycle, that is the next recursive call, and then here you have to find the mid value. Now the low index will be 5 and the high index will be 8. As I said previously, how do you calculate the mid index? Low plus high, the whole divided by 2. That is 5 plus 8 divided by 2, which will be 6. Now the mid will be 6 and the mid indexed value will be 20. So I have to compare whether 23 is equal to 20. No. Now I have to check whether 23 is less than 20. No. The third case will be 23 is greater than 20. Yes. So now that 19 and 20 portion has to be excluded from the given array. That is index 5 and 6 has to be excluded, and for the next cycle, next iteration or the next recursive call, you have to move on to the index 7 and 8 index has to be passed for the next cycle. Now low index will be 7 and the high index will be 8. Again the same process has to be repeated. How do you calculate the mid? Low plus high, the whole divided by 2. 7 plus 8, the whole divided by 2 will be 7. So we will not be rounding off. So make sure that you should not round off the given value. That is the average value should not be round off. So 7 plus 8 divided by 2 will be still 7. And now 23 is equal to the mid indexed value. Yes. So now we have to return the item's location. That is 7 has to be returned. So return location 7. That is the final result. If the element is not found, then as we saw in the linear search, -1 has to be returned. How do you return -1? That is the worst case, If low index is less than or equal to high index, you have to proceed. If not, you should not proceed. That is, if low is greater than high, then you have to stop stating that the element is not found in the given array and you have to return -1. So here is a code. Starting with the first parameter, array A, and then low index will be 0 and then high index will be 8 over here with the very first iteration to be passed. Here is the recursive code and the target value is x to be found. As I said before, if the low is less than or equal to high, that is if the array contains at least one element, then I have to check whether the target value is equal to the given element, is equal to the element in the array. If at all not, then we have to make a split up, right? So if low is less than or equal to high, you have to make a search process. If it is not, then you have to stop the process and return -1. And the mid is calculated using the formula low plus high the whole divided by 2. So once you calculate the mid index, then you have to check whether the mid index to value, that is a of mid, if it is equal to target. So if x is equal to a of mid, then you have to return the mid, that is the index alone it is needed. Next, the second case will be if the target value is less than the mid indexed value, what you have to do? You have to pass the left half of the array. How do you pass the left half of the array? Low will remain same and the high will be, first we have calculated mid. The mid indexed value is not equal to target value. So you have to skip that mid and then you have to move on to mid -1. So for the next cycle, you have to pass low to mid -1. So the opposite case is when you have to pass the right half of the array, you have +1 to high. So the given array is splitted with the mid index and the left half includes with range low to mid -1 and the right half includes the range mid +1 to high. And concluding with the analysis of recursive binary search, as the given code is recursive algorithm and you have to write a recurrence equation. So here, given n input, either one half of the array is been passed for the next cycle and hence t of n is equal to t of n by 2 plus 1 is the basic operation. So here the basic operation is comparing the target value with the mid indexed value is the basic search process. For each iteration, that is for each recursive call, the basic operation occurs or the basic operation is executed only once and hence t of n by 2 plus 1. So either one half of the array is passed for the next recursive call and hence t of n by 2 plus 1 is the basic operation count is 1. The comparison is being made only once for every iteration or for every recursive call. And the base case is t of 1 is equal to 1. Why do you write t of 1 is equal to 1? That is, if the array contains at least one value, then I have to check whether the target value is equal to the given value in the array. That is the existing value in the array. So t of 1. If the array contains only one element, t of 1 equal to 1. That is, I am comparing that basic operation is comparing target value with the existing value in the given array. So comparison takes place, basic operation takes place and hence t of 1 equal to 1. When you solve it, you get log n. So using backward substitution method, when you solve it, you get big O of log n, because we know that if the given input is divided by a constant factor for every iteration, the algorithm's running time falls under log n. So in the same way here, the given input is divided by a constant factor for every iteration. There is a constant factor of 2 for every iteration, and hence the algorithm's running time falls under log n. Thank you.